we're talking about is a sphere. That would be the set of all points in space equidistant from a given point called the center. So down here we have this sphere. We call it sphere B because B is our center point. And all the points that lie on the surface of this sphere are the exact same distance away from this center point, point B. Next vocabulary term is a diameter. That would be a segment passing through the center with endpoints on the sphere. So in our example down here, we're again working with sphere B, where B is the center of our sphere. Now, if we have a line segment that passes through that center point and has endpoints on the circle, like this line segment does, segment AC, then that line segment can be considered a diameter of your sphere. Now, a radius would be a segment that has one endpoint at the center and the other endpoint on the sphere. So, in sphere B down here, we have several different examples of radii. First, we have segment AB. Segment AB would be considered a radius of sphere B because it has one endpoint at the center of our sphere and one endpoint on the sphere. Segment CB would also be considered a radius of sphere B because it has one endpoint at the center of our sphere and one endpoint on the sphere. Segment EB would be considered a radius of sphere B because it has one endpoint at the center of the sphere and one endpoint on the sphere. And same thing with segment DB. Next vocabulary term is a great circle. That would be a circle formed when a plane and a sphere intersect, with the center of the circle also being the center of the sphere. So what this is saying is that a great circle is formed when you cut a sphere perfectly in half, making sure that you cut right through the center of your sphere. You can cut it any direction you want, just make sure that when you cut it, you go perfectly through the center of your sphere. Now, when you cut it, you're going to create a cross section that is a circle. That circle, whose center is also the center of the sphere, point B in this case, would be considered a great circle. Next vocabulary term is the circumference of a sphere. That would be the circumference of the great circle. So we just said to create the great circle, you need to cut your sphere perfectly in half, and that cross section, that circular cross section, would be considered the great circle. Now, the circumference of your sphere would just be the circumference of that great circle that you created. So if you want to find the circumference of this great circle right here, all you'd have to do is use the formula 2 pi r, where r would be one of your radii, either the measure of segment AB or the measure of segment BC. Next vocabulary term is a hemisphere. That would be half of a sphere. And a great circle divides a sphere into two hemispheres. So as you can see with our example down here, we again have sphere B. And we again are creating a great circle within sphere B. That would be this circle in here, circle B. Now, that great circle is going to divide your sphere into two hemispheres. This one would be a northern hemisphere and a southern hemisphere. Now, you could draw your great circle vertically, and that would create an eastern and a western hemisphere. You could draw it diagonally, and that would create two hemispheres as well. So just note that anytime you draw a great circle, anytime you cut your sphere perfectly in half, it's going to create two separate hemispheres. Now let's talk about the surface area of a sphere. So the surface area of a sphere is 4 times the product of pi and the square of the radius of the sphere. In other words, surface area is equal to 4 pi r squared. So this is one of the easier formulas you're going to see this chapter. If I want to find the surface area of a sphere, the area of all of the outside of a given sphere, all I have to do is just find the measure of one of the radii. So in this case, I would take the measure of segment AB or the measure of segment CB. If I squared that and multiply it by 4 and pi, that gives me our surface area. Now, one thing I want you to note that you'll definitely run into today is that when you're finding the surface area of a hemisphere, half of a given sphere, it's not just going to be 1/2 times 4 pi r squared or 4 pi r squared divided by 2. What you're going to have to do is think about when this part of your sphere goes away and you're just left with half of a sphere. Yes, you're going to have half of 4 pi r squared, but you're also going to have a base now that is a circle. So it's going to be 1/2 times 4 pi r squared plus the area of your circular base that your hemisphere now has, which would be pi r squared. So again, to find the surface area of a hemisphere, that would be 1/2 4 pi r squared plus the area of the base, which would be pi r squared. And we'll go over that in depth later on.
I saw Mama kissing Santa Claus underneath example time last night.
Now example 1 says find the surface area of the sphere with the given diameter or radius. Round your answer to the nearest tenth. So in part 8, we're given a sphere with a diameter of 20 meters, and we're tasked with finding the surface area of that sphere. Well, in order to find the surface area of a sphere, you need to remember the surface area of a sphere formula. Surface area is equal to 4 pi r squared, where r is the radius. Oh, but we're not given the radius, we're given the diameter. Well, how do you find the radius if you're given the diameter? You just take the diameter and divide it by 2, or multiply it by half. If the diameter of the sphere is 20 meters, that means the radius of this sphere is 10 meters. So I can take 10 meters, plug that in for our radius right here, and now all I have to do is just square this. I get 100, multiply that to 4 pi, I get 400 pi meters squared. This would be the exact surface area of a sphere with a diameter of 20 meters in terms of pi. But this question doesn't want the exact surface area. It wants you to round your answer to the nearest 10th. So in your calculator, you can take 400, multiply it to pi, and round to 1 decimal place. And you get that the surface area of this sphere with a diameter of 20 meters is approximately equal to 1,256.6 meters squared. For B, we again want to find the surface area of a given sphere, and this time we're given that the sphere has a great circle whose area is 25 pi feet squared. So in order to find the surface area of a sphere, we got to use the surface area of a sphere formula. Surface area is equal to 4 pi r squared. So how do I find the surface area if I'm only given that the area of a great circle in this sphere is 25 pi feet squared? Well, I clearly need to find the radius. So I'm going to use this in order to help me find the radius of our given sphere. Now the way I'm going to do that is because I know the area of a great circle is the same thing as the area of a circle, which is just pi r squared. What I can do is take the area of our great circle, which is 25 pi feet squared, plug that in for A, and solve for r, because the radius of our great circle is going to be the exact same radius as the radius of our given sphere. So if I can solve for the radius of the great circle, it will equal the radius of the sphere, and I can use that to find our surface area. So that's what we're going to do. I'm going to take 25 pi feet squared, plug that in for our area here, and I can solve for the radius of our great circle slash the radius of our sphere. So to solve this for r, I'm going to divide both sides by pi. I'm then going to square root both sides to get the r all by itself. And remember, anytime you square root a variable squared, on the other side you need to put plus or minus. Now, on this side of the equation, the square root and the square just cancel each other out. On this side, because I'm dealing with the radius of a circle, we're just going to take the principal root, the positive version, because we can't have a circle with a negative radius. That doesn't make any sense. So I'm going to say the radius of this great circle, which is the radius of our sphere, is going to be equal to 5 feet. Now that I found the radius of our sphere, all I have to do is take that and plug it into the surface area of a sphere formula. Surface area is equal to 4 pi r squared. So I take 5 feet, plug that in for r, our radius, and now all I have to do is just square that, multiply it to 4 and pi, and I get that the exact surface area of this sphere with a great circle whose area is 25 pi feet squared is going to be 100 pi feet squared. But I don't want the exact surface area. This question wants you to round your answer to the nearest 10. So in your calculator, you're going to take 100, multiply it to pi, and round to 1 decimal place, and you get that the approximate surface area of this given sphere is going to be 314.2 feet squared.
Try this and be on the nice list.
Okay, doing the same thing. Part 8, we want to find the surface area of a sphere with a diameter of 22 centimeters. So in order to find the surface area of a sphere, you need to remember the surface area of a sphere formula. Surface area is equal to 4 pi r squared. So in order to find the surface area, we need the measure of our radius, but we're given the diameter. So we're going to take that diameter, divide it by 2, and that'll give us our radius. So the radius of this sphere is going to be 11 centimeters. So I can take 11 centimeters, plug that in for r right here. I square that and then multiply it to 4 and pi, and I get that the exact surface area of a sphere with a diameter of 22 centimeters is going to be 484 pi centimeters squared. But I don't want the exact surface area. This question wants you to round your answer to the nearest 10. So in your calculator, you're going to take 484, multiply it to pi, and then round to 1 decimal place, and you get that the approximate surface area of this given sphere is going to be 1,520.5 centimeters squared, or square centimeters. Part B, doing the same thing, we again want to find the surface area of a sphere. But this time, all it gives you is that the circumference of a great circle is going to be 200 pi inches. Well, in order to find the surface area of a sphere, I obviously need to use this formula. Surface area is equal to 4 pi r squared, meaning I just need to find the radius of this given sphere, and then I can find the surface area. So how do I find the radius? Well, in order to find the radius, I'm going to have to use this information. Remember that the radius of a great circle is actually equal to the radius of our sphere. So all I really need to do is just find the radius of this great circle with a circumference of 200 pi inches. So what I'm going to do is I'm going to use the circumference formula. Circumference is equal to 2 pi r. I'm going to take 200 pi and plug that into our circumference here. And now the only variable that's left in this equation would be our radius, and I can solve for the radius of this great circle, which is equal to the radius of our sphere. So how do I solve this for r? I just divide both sides by 2 pi, and I get that the radius of our great circle, which is equal to the radius of our sphere, is 100 inches. So now I could take that radius and plug it it into the surface area of a sphere formula. Surface area is equal to 4 pi r squared. So I take 100 inches, plug that in for r. I then square this, multiply it to 4 pi, and then I get that the exact surface area of this given sphere with a great circle whose circumference is 200 pi inches is 40,000 pi inches squared. Now, because this question doesn't want you to find the exact surface area, it wants you to round your answer to the nearest tenth, what I'm going to do is take 40,000, multiply it to pi in my calculator, and round to 1 decimal place. And I get that the approximate surface area of this given sphere is 125,663.7 inches squared, or square inches. Now, example 2, doing the same thing. We are given a sphere, and we are tasked with finding the surface area of this sphere. Well, in order to find the surface area of a sphere, you need to remember the surface area of a sphere formula. Surface area is equal to 4 pi r squared. In this sphere, we are given that the radius of this sphere is 6 feet. So all I have to do is take 6 feet, plug that in for our r right here, square that, and then multiply it to 4 pi out front. Now I get that the exact surface area of this sphere right here with a radius of 6 feet is 144 pi feet squared, or square feet. But this question doesn't want the exact surface area. It wants you to round your answer to the nearest tenth. So in our calculator, we take 144, multiply it to pi, round to 1 decimal place, and we get that the approximate surface area of this sphere with a radius of 6 feet is 452.4 feet squared, or square feet.
You won't end up with a lump of coal if you try this.
Okay, doing the same thing. Again, part A, we want to find the surface area of the sphere. In order to find the surface area of a sphere, you need to remember the surface area of a sphere formula. Surface area is equal to 4 pi r squared. In this figure, we're given a sphere with a diameter of 8.2 inches. That is not the radius. So what we have to do then is take that diameter, divide it by 2, and that'll give us our radius. So what's 8.2 inches divided by 2? That would be 4.1 inches. So I can plug that in for r over here. Now all I have to do is just square this, multiply it by 4 pi out front, and I get that the exact surface area of this given sphere over here with a diameter of 8.2 inches is 67.24 pi inches squared. Now, this question doesn't want the exact surface area. This question wants you to round your answer to the nearest 10. So what I'm going to do is take 67.24, multiply that by pi in my calculator, round to 1 decimal place, and I get that the approximate surface area of this sphere with a diameter of 8.2 inches is 211.2 inches squared, or square inches. Part B, doing the same thing. We want to find the surface area of this hemisphere this time. Okay, so this is where it gets interesting. Remember, to find the surface area of a sphere, the surface area formula is surface area is equal to 4 pi r squared. But in order to find the surface area of a hemisphere, we take half of that surface area of a sphere formula. So it's going to be 1/2 4 pi r squared. But this time, we have a base, and our base is a circle. And if we're finding the surface area, which would be the area of all of the outside of this given hemisphere, we have to include the area of that circular base. So our surface area formula for a hemisphere is going to be 1/2 4 pi r squared. That'll give us the area of this outer shell. But then we add in the area of that base, which is a circle, which would be pi r squared. That is the surface area of a hemisphere formula. Now again, just like the surface area of a sphere formula, all we need is the measure of our radius, which they give us. It's 8 feet. So we're going to take 8 feet, plug it in for our radius here and here. We could also take this 1/2, multiply it to 4, and just make that 2 pi out front. Now all we have to do is just square the 8 feet here and here, multiply that 64 by the 2 pi, multiply this 64 by the pi. We then add these two quantities together, and we end up getting that the exact surface area of this hemisphere right here is 192 pi feet squared. But this doesn't want the exact surface area. It wants you to round your answer to the nearest 10. So we're going to take 192, multiply it to pi in our calculator, and round to 1 decimal place. And we get that the approximate surface area of this hemisphere is 603.2 feet squared, or square feet. Now let's talk about the volume of a sphere. So the volume of a sphere is 4/3 times the product of pi and the cube of the radius of the sphere, or V is equal to 4/3 pi r cubed. Now remember, volume is just the amount of space, three-dimensional space, that this sphere is going to take up. So if I want to find the volume of a sphere, I need to use this formula, 4/3 pi r cubed. Again, the only thing you need is the measure of your radius, just like the surface area formula. Now, people mix up these two formulas all the time, the surface area and the volume formula for a sphere. It's actually pretty easy to remember, because if you're talking about area, you're dealing with square units. So you should use the formula that has a square in it. Whereas volume, you're dealing with cubic units. So you need to use the formula that has a cube in it. Now, example 3 says find the volume of a sphere with the given diameter or radius. Round your answer to the nearest tenth. So in order to find the volume of this sphere, what we need to do is remember the volume of a sphere formula. Volume is equal to 4/3 pi r cubed. So all we need is the measure of our radius, which they give us. It's 12 meters. So I'm going to take 12 meters, plug that in for r right here. Now all I have to do is just cube that, then multiply that to 4/3 and pi out front, and I end up getting that the exact volume of this sphere right here is 2,304 pi meters cubed, or or cubic meters. But because this question wants you to round your answer to the nearest tenth, in your calculator, you're going to take 2,304, multiply it by pi, and then round to one decimal place. You get the approximate volume of this sphere up here is 7,238.2 meters cubed, or cubic meters. For B, doing the same thing, want to find the volume of this sphere. So in order to find the volume of a sphere, you need the volume of a sphere formula. Volume is equal to 4/3 pi r cubed. So in order to find the volume, we need the measure of our radius. But this time they only give us the diameter. So how do we do this? Well, we're going to take the measure of our diameter divided by 2 in order to get the measure of our radius. So 6 inches divided by 2 is going to be 3 inches. So we can take 3 inches, plug that in for our radius. Now all we have to do is just cube that and then multiply it by 4/3 and pi out front. And we end up getting that the exact volume of this sphere right here is 36 pi inches cubed, or cubic inches. But we don't want the exact volume. We want our answer rounded to the nearest tenth. So we're going to take 36, multiply it by pi in our calculator, and round to one decimal place, and we get that the approximate volume of this sphere up here is 113.1 inches cubed, or cubic inches.
I'm busy making presents. Why don't you try?
Okay, doing the same thing, want to find the volume, but in part A, we're given a hemisphere. So what do? Well, again, in order to find the volume of a sphere, we use the formula volume is equal to 4/3 pi r cubed. To find the volume of a hemisphere, all we have to do is just take half of that volume of a sphere formula, 1/2 4/3 pi r cubed. Now, the reason we don't have to add pi r squared at the end here is because we're just talking about volume. We're just talking about the three-dimensional space that this figure takes up. We're not talking about the surface area. So all we need is just half of that given volume of a sphere formula. So what is our radius here? That would be 10 centimeters. We can plug that in for r right here. We then cube that and multiply that to 1/2 and 4/3 pi out front. And we end up getting that the approximate volume of this hemisphere, when we round to the nearest tenth, is going to be 2,094.4 cubic feet, or feet cubed. For B, doing the same thing, want to find the volume of a sphere. In order to find the volume of a sphere, you need the volume of a sphere formula. Volume is equal to 4/3 pi r cubed. So in this figure, what is our radius? Well, it doesn't give us that. It gives us the diameter. So we're going to take our diameter divided by 2 to get our radius. So what's 9 meters divided by 2? That's 4.5 meters. That's going to be our radius. Plug that in for r. We then cube that and then multiply that by 4/3 pi out front, and we end up getting that the exact volume of this given sphere up here is 121.5 pi meters cubed, or cubic meters. But this doesn't want the exact volume. It wants you to round your answer to the nearest tenth. So we take 121.5, multiply by pi in our calculator, round to one decimal place. We get the approximate volume of this sphere up here is 381.7 meters cubed, or cubic meters. Now, word problem says a tetraodontidae, or a pufferfish, is able to puff up when threatened by gulping water and inflating its body. The pufferfish below is approximately a sphere with a diameter of 5 inches. Its surface area, when inflated, is about 1.5 times its normal surface area. What is the surface area of the fish when it is not puffed up? Round your answer to the nearest 100. So step 1 in the word problem. We're not scared. We can do this. Step 2. What is this question asking us to find? It says, what is the surface area of the fish when it is not puffed up? So that's what we're trying to find. Well, does it give us any clues to help us figure this out? Well, it says the pufferfish below that is puffed up has a diameter of 5 inches, meaning that its radius would be half of that. So that would be 2.5 inches. Okay, that doesn't really help us, but what else does this say? It says its surface area when inflated is about 1.5 times its normal surface area. So what I could do is, if I know the radius of our pufferfish when it's puffed up, I could find the surface area of this pufferfish when it's puffed up, and then I could divide that by 1.5, and that would give me the normal surface area of our pufferfish when it's not inflated. Okay, so let's do that. So let's find the surface area of this puffed up fish. Remember, surface area of a sphere formula is surface area is equal to 4 pi r squared. So I'm going to take my radius here, which is 2.5 inches, plug it in for r. I then square that and multiply it by 4 pi, and I get that the exact surface area of this pufferfish when it's puffed up is 25 pi inches squared, or square inches. Now, I know this question says round your answer to the nearest 100, but this, again, is not our answer. We're trying to find the surface area when it's not puffed up. So don't round too early. If you round too early, you're going to get the wrong answer. So we're going to use this now in order to help us find the surface area of the not puffed up pufferfish. So again, this question says the surface area when inflated is about 1.5 times its normal normal surface area. So what I know is that if I were to take the surface area of the normal not puffed up pufferfish and multiply that by 1.5, it would give me the surface area of our puffed up pufferfish, which we found to be 25 pi inches squared. So all I have to do to find the normal surface area of our pufferfish would be divide both sides here by 1.5. And I end up getting that the surface area of the not puffed up pufferfish, the normal surface area, is going to be approximately equal to 52.36 inches squared, or square inches, when I round to the nearest hundredth. Now again, please don't forget that this is a word problem, so don't just leave your answer as SA is approximately 52.36 inches squared. You need to answer the question. You need to say that the surface area of the fish when it is not puffed up is about 52.36 inches squared, or square inches.